Okay, right now we in question 10a. In question 10a, they say that the diagram below shows a solid right circular cone that is set centrally within a hemispherical container, right? And they say that the radius of the hemisphere, is 5 times square root 3 centimeters. Of all possible right circular cones that can fit into the sphere, calculate showing all working the value of x height of the cone in centimeters, for which the cone will have a maximum volume. Let radius of cone be p centimeters, and we are given the formulas, which is volume of a sphere 4 over 3 pi r cubed, volume of a right circular cone equals to 1 over 3 pi r squared times height. Alright, now what we can do now to use what we are given in the question, we are told that the height is x, right? And then we are also told that the radius is basically p for the cone, right? Now another thing, we are told that the radius of the hemisphere is 5 times square root 3. Now that radius can either be there, or it can either be there, or it can either be there. It's up to you where you find it. But also, one thing that I need you to be careful of is also that the radius can actually be this there, basically. Let me just do this. Yes, so basically that radius can also be that thing there. So remember, because remember the radius is always the same everywhere else, so we can write 5 square root 3 and write 5 square root 3 there, because the radius is the same there. So let's just write this out there and just leave it in being only there. All right, now can you see that this forms a right angled triangle? Can you see that this is forming a right angled triangle where we have the height being x, we have the opposite side also being just p, and we also have the radius being 5 square root 3. Remember, we have a shape. Let me draw the shape for you, right? Okay, and we have x there, we have 5 square root 3, and we have a p there, right? Now remember, what we're gonna try to do, we're gonna try to make p in terms of x. So we're gonna try to make p to be in terms of x. Now to do that, we're gonna say that 5 square root 3 squared equals to x squared plus p squared, which is actually called a Pythagorean theorem. Alright, so we're gonna use the theorem of Pythagoras. Alright, and then if we put 5 square root 3 in a squared, we basically gonna get 75 equals to x squared plus p squared, right? And then if you take the p squared to the if you take the x squared to the other side, you're basically gonna have p squared being 75 minus x squared. Then if you wanted to just find p alone, you're gonna basically square both sides. Alright, now remember, in maths, whenever you do square both sides, you gotta always put a plus or a minus there. Whenever you do square both sides, you gotta always put a plus or a minus. But what I want you to be careful of, we are dealing with lengths. Length cannot be negative, so we gotta just take a positive answer. So basically our p, it should be the square root of 75 minus x squared, which is in centimeters. Okay, now so we have everything else. Now what we're gonna do, remember we are told that the volume of the cone It's given as 1 over 3 pi r squared. Right, so we're given that the volume of the cone is 1 over 3 pi r squared multiplied by height. Now let's substitute all of this. So we're going to have 1 over 3 multiplied by pi r. Now we have it p, which is our r. We have it as actually just going to be, if we had to put that in a square, it's basically just going to be, let me show you. If you had to say 75 minus x squared all over squared, and now remember your heights we are given as being x, okay? It was basically gonna be pi over 3, and then if you put anything, if you square a root, you're gonna basically just get 75 minus x squared times x. Now what we're gonna have to do is now multiply the pi over 3 and the x inside the bracket there. Now if you do that, you're gonna get 1 over 3 times 75, 25. So you're gonna get 25 pi x, and then you're gonna get minus pi over 3x cubed. All right, so this is the answer that you're basically gonna get. You're gonna get 25 pi x minus pi over 3x cubed, which is the volume. Now in the question they say that you must find, showing or looking the value of x, heights of the cone in centimeters, for which the cone will have a maximum volume. For us to do that, it means that now we're gonna have to do the first derivative. Basically we can just say dv over dx. It's the same thing, right? V prime. We can just say v prime of x. Let me just do this. We can just call that v prime of x, which is basically just dv over dx. It means that we need to do the first derivative of, let me just call that volume there, let me just call it vx, right? Let me just call that vx. All right, so if I do the first derivative of that function, I'm gonna get 25 pi minus pi x squared. All right, so I'm gonna get 25 pi minus pi x squared. Now the other thing that I gotta do now, after doing that, for me to solve for x, I'm gonna have to say v equals to dv over dx. I must set it to 0. All right, now if I do that, I'm gonna say 25 pi minus pi x squared is gonna be equals to 0. And then what I can basically do, I can just take out the pi there. So I'm gonna be left out with 25 minus x squared equals to 0. And then if I divide both sides by pi, dividing both sides by pi, basically it's just gonna be 25 minus x squared, which is gonna be 0. Now I can factorize that, so I can say 5 minus x, 5 plus x is gonna be equals to 0. Now separating the brackets, equating to 0, it's gonna be 0, or 5 plus x equals to 0, and that will be just equals to 5, or x equals to minus 5. Now can you see that here we are still dealing with the length, because x is a height, so it's a length. So that cannot actually happen. So we're going to have to say, therefore, x equals to 5 centimeters. Because remember, oh, sorry, it's 5 centimeters because remember, length is always positive. Length is always positive. Alright, so basically that's how you could have solved that whole entire question there. Alright.